Hey, welcome to Coffee Compiler Club. Here today talking about whether or not my cat will take down my monitor in the middle of Coffee Club, or about compilers, or about Emacs implementations in Rust. That sounds like a really fun one. Language runtimes, typing systems, everything to do with language compiler implementations is all fair game. We're all recorded. We'll show up on YouTube in a few hours. And that's the end of my spiel. We have a new guest today, Troy Hinckley, who was talking about Emacs and Rust. And I was thinking that sounded very interesting. So you want to give like the 30 seconds?
Yeah, sure. Yeah, so I'm working on a project that I call Rune, which stands for Rust under Emacs. I don't really love the name, but I haven't come up with anything else. And so it's basically trying to re-implement core functionality of Emacs in Rust. Kind of started it just as a learning project because I wanted to learn Rust, and I was interested in interpreters and compilers, and so everything kind of came together. And I've been using Emacs, and I love Emacs, so it all kind of came together in a big ball. And I started working on this project. And so it's got interpreters, got a garbage collector, it's got a compiler to bytecode, and it's been really interesting.
And you're running the bytecode as you're not jitting actual like x86 or anything. You're running the bytecode as the interpreter.
Right, no JIT yet.
No JIT yet. Excellent.
But I've been looking at Crane Lift and some other libraries they have for doing that. But I got to keep telling myself that's down the road.
Okay, why? Because I found Emacs is like pretty stable.
It is. It is pretty stable, and it's got native compilation, so it's pretty decently quick. The real reason is because I wanted to try this out, but there's been some nice benefits I picked up along the way. The one, and I've written a blog post about this, is because the way that Rust tracks ownership and lifetime, we have a fully moving collector that is safe. In other words, the compiler will tell you if you have something that needs to be rooted that isn't rooted. And so it can completely track all the lifetimes of your values as you go through. And you don't have to worry about getting GC bugs where you forget to root something.
Wait, so start with the link, and we're going to throw it in the docs. So you can throw the link in the chat if you want, or follow the Google Doc link and add it either way.
Yeah, let me just jump back over and grab it.
And then you're tracking lifetimes. And somebody copy that, please. Into the docs.
Yeah, let me pull up the chat.
Theodore through the docs. Oh, that's docs in the link. Thanks, Theodore. I'm backwards. There you go, Troy. Got it. Okay. That's what I'm looking for. And it's done. Thank you. It's probably Theodore. Okay, wait. Back up. How are you tracking the compiler? Like the usual Rust stories, you get like massive annotation depth. Are you like massive annotation depth, or you have some more clever answer?
So we're using a lot of macros to try and avoid some of the all the objects have an annotation on them, but we try and elide them as often as we can. And I generally kind of see it as a code smell. If I have to add a lot of lifetime annotations, that means something's not right.
You're writing Rust code with macros to hide annotations.
Not to hide annotations, but to set up because the problem with setting up a root is that you need to know exactly how long it's going to live.
Right.
Like we're going to root an object on the stack, and we need to tell the GC about that so we can go trace it. But everything in Rust is movable. And so someone could inadvertently go and move that value that we had as a root, put it somewhere else, and the old value gets dropped, and now you have a problem. And so we use macros to basically hide the creation of the roots. And then everything just kind of falls out from that.
This sounds very interesting. Why can I not follow the link in the Google Docs? Hello, Google.
Open that Google Doc.
Okay. Yeah. Sorry, unrelated. Wife's off doing vacation-y things because I'm doing this. Okay, so wait, is this link? Why is this link not letting me click on it? Here, this one will let me click on it. Click, blah, 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 click. Oh, and you have a large one. I saw some other post. And this is, you're using garbage collection in Rust. So it's like where you sidestep Rust's.
No. So this is implementing a safe garbage collector. So it's for the host language for Lisp.
implementing. Okay, when you say implementing the garbage collector you're implementing in Rust, where is its heap? What does Rust think the heap is? Thinks the heap's a giant ass big array?
Yes, I'm using a bump allocation crate,
Right.
and that is essentially the heap.
Okay, so you just picked up a crate that's got a bump allocator in it already.
Yeah, and I've written another post about bump allocation.
Is you a moving collector?
It is.
It is a moving collector. Very interesting.
Well, and the property of Rust makes it useful because I can make it moving, but we can also guarantee safety. Like I don't have to worry when I'm coding something up that I'm going to accidentally screw something up and then the value is going to get moved and dropped.
Well, okay, so safety in this case means the garbage collector works like a correct garbage collector, as opposed to safety meaning that you'll never run out of memory.
Well, safety here means that I, as a programmer, as a user of the garbage collector API, can't make a mistake that leads to a use after free or a double
Oh,
free or
I
something like that.
see. Yes, because you're using the GC directly in your implementation of the list, but another person using this GC to write some kind of a heap managed structure using Rust would also be able to, in theory, not screw up the entry points into the GC. That's interesting.
Right. Assuming that everything is sound, which I found some soundness bugs and had to fix those, and that's the real kicker.
Yeah, well, fine. Bugs are bugs are bugs. Okay, that's an interesting one.
Soundness bugs in where? Like in the bumping library or?
No, in my implementation, in my
Oh.
API for the garbage collector.
Yeah. Most of us here are doing personal language implementations of one flavor or another. Not everybody, but a lot of people are. And so there's always, you get bugs in implementation. Don't bother with fancy name like soundness on your bug implementation. Just got bug in your implementation. Fine.
The only bugs that I find difficult is code generation. Those are so annoying to track down.
I thought you were spitting out C code to TCC.
Yeah, but it's well, okay. It's been a while since I touched it, but I just remembered it being very annoying. It's manageable, but it's just really annoying compared
You
to
mean the
other
actual
bugs.
code generation to C code?
Yeah, because like it's not just the C code because I have to get more than one backend to match in their output, but the issue is like one backend expects it one way and another backend expects it another way, and you can't just reuse the same code, so you have to tweak everything. And if you forget to tweak something, you get output. It compiles, but it's not correct. So
Not correct. Yeah. Fine.
yeah,
Yeah, it's pretty common. Yeah, well, start dumping machine code out, and then you can get a whole new set of those things. I think both Haley and Yasser are actively doing register allocators now, and that's a different level of output, but you get your own set of bugs out of those that all generate code. It just doesn't run worth shit. Okay,
So-
Levo, did you want to show you were working on a hash table? I wanted to see your hash table implementation because you're like the I don't do things with memory, no memory allocation guy.
it's really bad, but I can show you why it's bad.
See, instead of demeaning yourself, just show us, and we'll see if we think it's all good or bad or whatever.
Let me just get it to compile. So give me like 5 minutes, and then 'cause it's not compiling at the moment.
But the mid hack of everything.
Ah,
No, most I
Adrian,
wanted to see what you're doing with your memory management game.
while Levo gets that, Adrian, I think, had a question.
Oh,
Yeah,
this
just
view,
I was
can't
curious.
help.
I want to ask Troy, like, what is your, I guess, long-term or general ambitions for this Rune project?
Oh, I mean, the ultimate goal that everyone thinks is awesome, and they decide to use it as the core implementation of Emacs. But given that's not super likely, I would like to see it, basically see how far we can take it and see what advantages it provides. There's a bunch of different ideas I want to try and implement with it. Like I said, I think the GC is really powerful because it is moving and it is precise. As well as there's some libraries from Rust that I think could be really beneficial, like Crane Lift for generating JIT code, and the regex library is really high performance.
So what do you envision would be like reasons why Emacs users would want to prefer your core? Like, would it
Oh,
be
one
faster
thing-
performance or
Yeah,
latencies?
yeah, performance is one. But one thing I forgot to mention is that Rust doesn't really have a concept of single-threaded code. Everything has to be designed in a way that supports multi-threading. And I tried fighting that a lot at first, and then eventually I just kind of embraced it. So Rune actually has support for multi-threaded eLisp. It can run Lisp on different threads, and they can communicate with each other. And I have another post talking about that as well, talking about
Interesting. And
multi-threading.
the current implementation, I guess it's a C implementation or something.
Yeah,
That
it's a
one
C core.
is single threaded or what?
Yeah, it is single-threaded.
I see.
And they've made some attempts to try and add some threading to it, but everything is designed around the assumption that it's going to be single-threaded.
Yeah,
doesn't that cause? Sorry, yeah.
Try that.
Doesn't it cause issues? So like from the perspective of the person who writes, I guess eLisp is the
eLisp,
language called,
yeah.
And
No,
so from their perspective, are they writing like not single-threaded semantics? Like, or like how does this like programming in eLisp look like? Can you write it in a way that it can like be parallelized by the core, or like what is the idea?
So every window in Emacs is doing something, and you can imagine wanting to have the windows running in parallel. There's some core logic that says I'm making a window, I'm moving a window, I'm removing, adding, whatever. Maybe that has to be single threaded. Within a window, the two different windows are generally independent.
Interesting. And so they don't need to share like mutable state or anything.
Not
So-
typically.
So how come I'm just curious, like how come the core doesn't, the current implementation doesn't do multi-threading if
Well, it's
if
because
it has
dates
already
from
this?
the fucking 50s, I guess 60s.
Okay, cool. Yeah, I think it's
Well, ask Troy. I'm a user, not a writer.
So yeah, I mean, Cliff brought up a good point, and you were talking about Adrian about mutable state, and that's the hard thing is that from an implementation perspective, it's not that hard to make a multi-threaded runtime. What is hard is trying to make a interface to it an eLisp that's not absolutely terrible, that you don't have all sorts of crazy bugs. And so I just put a post in there talking about kind of like what does concurrency look like in Emacs Lisp, where it is just a giant ball of mutable state. And where could you actually partition things off, like Cliff was saying, like so windows generally operate independently, even though they can share state and they can talk to the same global variables. How do you partition that off so you can actually get useful work done without, making programmers want to pull their hair out because they pull in 10 multi-threaded plugins and all of a sudden they're clobbering each other all over the place and nobody can figure out what's going on. And so it's kind of based on like an actor model where every time you start up a new eList thread, it can lock individual buffers to operate on those buffers, but everything else within its state is local to it. So if it updates variables, it only sees those changes. But
Well,
it's a really interesting question. Yeah.
Well, then you
Cool.
get you have to find a way to buffer local set variables and stuff. Like,
Yep,
like,
local is interesting.
like my, what the hell they call the thing that you're running a command buffer, I'm running like the compile on a buffer. And it's spewing and spewing and spewing, and it's parsing out e-messages or whatever, error messages, and I can go tap around. But I might have another buffer running around doing something else.
Mm-hmm.
And so I can imagine there being a use for parallelism.
Well, that's an awesome use case because really the Emacs runtime has to wait until it's idle before it can process new output coming from the process.
Oh,
And
yeah.
so that can really slow it down.
Yeah, I totally know that. And if it's spewing too much, then the buffer can get slow or get behind or something while it's playing catch up.
That's one metric I think would be interesting to benchmark, once we get more things put in place, would be how fast can it sync input? Because compared to something like a normal terminal, Emacs is very, very slow at syncing input. Like if something's just dumping, like a giant file.
Get grep running into a buffer.
It's very, very slow.
Yeah, I wouldn't mind that being faster. I grep into buffers a fair amount. It happens.
Yeah.
Cool. Thanks for answering and elaborating.
Sorry, what, Adrian?
I said thanks for elaborating.
Yeah.
So, Levo, if you're ready.
Yeah, I want to see Levo's code.
Okay, sure, but I don't know how many of us does C++. It's going to be very boring. It's disabled, by the way.
Oh, yeah, hang on. Sorry, it's disabled by default, and then I've had issues in the Misty past. Now, it's actually been a long time. I probably should find a way to enable by default. So There it goes. Something happens. Hey. This is.
It turns out I left myself unmuted. How's the font size?
It can be a little bigger.
Yeah, it's okay, but yeah, a little
That's
bit.
fine.
Yeah,
That's fine.
that looks good.
Okay. Let me just run this.
This is
that's-
your IDE, right?
No. This is VS Code.
Oh, VS. I see it now. Yeah. Okay.
It turns out Clang gives me a lot of problems just because it's not the same quality as the Microsoft's C++ extension. So I haven't gotten used to it, and I didn't finish fixing all my bugs. So I'm still mostly using VS Code, unfortunately, but I'm pretty close to being able to switch. So okay. So the first thing is I just want to show the hashing. So C++ has a constant expression. Why is this not jumping? That's kind of annoying.
Oh, so okay. I was trying to figure out what the hell you were there, but you got some macro going on. Fine.
Yeah. So just take a look at the macros for just a moment.
Right.
Um,
And what's hash do? You're getting
Const expression.
hashes? You're getting perfect hashes?
that's exactly what I was going to show you. Yes.
Yeah,
Constant
perfect. Yeah,
expressions.
const expression has to reduce to literal.
That is reducing to a const expression.
Yes, I have no idea how they managed to
Wow.
pull that off.
I mean, I
but
see all numbers, so it's all just plain math. Sure. Your
Yeah.
compile time interpreter is busy compiling this at compile whatever, interpreting this at compile time.
So the keys
Wow.
are known at compile time, correct?
Yes, and it's still actually pretty fast. I think I tested it, and you know what? Let's do a clean build.
What did you use to create your hash code or your hash function?
Murmur hash 64. So I highlighted it
Oh,
right
I see
there.
that. I see that.
Time. Yeah, so it's less than 400 milliseconds.
Do
and I
what?
have hash code, and I run this.
400 milliseconds to what?
Yeah, to do what?
No, it's less than 400 milliseconds to compile this entire thing.
Oh, to
with,
compile. This is not your compiler then.
No. This is let's just do clean. So what I'm doing is I'm using Clang to compile. It's less than 400 milliseconds. Oh, actually, this is parallel, but so it's not.
No, that's fine. So wait, so you're saying that Clang is evaluating that constant hash expression as part of the
Yes.
compile time.
Yes.
So you're trying to say that the number you get for the milliseconds is take these 7 strings and do the perfect hash evaluation on them.
It's not perfect hash, but yes, it hashes these strings, and it's still less than 400 milliseconds.
It's extremely unlikely to have a collision, but if you have a collision, can you tell it? Can you tell that?
Yes. So
I mean,
so this is actually this is a slice, and this slice is my own implementation. And it has a operator overload on both comparing with a slice and comparing with a string. So what's happening here is hopefully this will jump back. So the switch case is on the hash value. This is 64-bit hash value.
right.
Then it does this,
Oh, okay.
which is overloaded to X, which is X is the actual string.
Yeah.
So this does so it takes your input, it hashes it, which is right here.
Mhm.
Then it already has a couple strings with the hash values for the case statements, and then it does another compare, which is just going to hit back a few times.
Okay, why are you
And it does a memory compare with the full string.
why are you doing what's your goal to accomplish here? Sorry, I didn't understand the goal.
Oh, I just wanted it something fun to implement, and I had the hash tables. I mean,
This is not a hash table. You have
I meant
a set.
I had the hash as a constant expression, and I was thinking, I wonder if I can make switch cases handle strings in C++, and there you go, it works.
Well, you have a set of fixed strings, like
Yeah.
a standard hash tables, like took the strings from a disk file and had to hash them, for instance.
Yeah.
So does it evaluate the switch at compile time then?
Yeah.
Yes.
No, well, the cases are.
Right.
The inputs are not. He takes an array, his car array there,
Oh yeah.
Yeah.
and just runs them
Compares it.
through.
Okay.
Like go
Just
grab
to warm
the
up what I was going to explain for the hash table. So what's your question?
go grab the billion row challenge and the data set from it, and and it's got a billion rows with 10,000 unique cities. And the length of the cities is between, 5 bytes or 5 characters and 64 or something. It's not out of control. But there's a billion of them, so you're not putting them in a table like that.
Yeah.
And that would be have a hash table now. And then of course you're doing, group bys or joins or whatever. So you're doing group by, so you want to hash all those cities.
So this is statically known at compile
Yeah,
time.
he's
So the
got a
keys.
list of statically known keys. He's got it. No, it's better. He's got a function which, given a statically known string key, will return you a statically known hash for it, which is kind of cool. I mean, I certainly do a lot of things in languages where I have a set of well-known strings.
The input is just my test case. Is not there's no constant expression on that. Like the optimizer can figure it out, but this is just a debug build.
Yeah.
I believe debug builds will have to execute the hash during compile time.
During compile time.
I think it does. I'm not 100%, but
I thought constant. Yeah, const expr. I thought it always at compile time it's turned into a constant.
Yeah, but for during debug
const
build is the question.
Const expr has no guarantee about compile time evaluation, as I remember.
Really?
So if it's very different from something like D, or definitely different from Zig or anything. So const expr is the best effort thing. So
I see.
I'm
sorry.
actually
I assume
I'm actually not sure how to like force it in C++. Maybe there is a way, but yeah.
I remember that it gives you a warning if you cannot reduce it to a constant.
Well, warning's got to be best effort too, though. Like some compiler will warn you and some doesn't, maybe? I don't know.
Oh, so you can put non-const code instead of const expression?
I think so, yeah.
Yeah,
I don't think so, because I had the compiler complain that it didn't like me typecasting.
Oh, okay, so the language spec says it has to be const code, but also the spec says, and also no guarantees will turn it into a constant.
Well, I believe
you can use something called const eval that's in C++20, and that guarantees it's going to be evaluated at compile time.
And
you can also check whether the function is evaluated at compile time inside the function and do a branch, because some things you can only do at runtime. For example, SIMD intrinsics only work at runtime. Yeah. So if you would like to write a function that is efficient, it has runtime data, but computed at compile time, it has compile time data. This is often what you do.
Right. So
I don't use constant expression too much. I use it when I need the variables to be usable globally, because sometimes I want to assign if I want to do something like U64 my var equals. Sometimes I want to do this, so that works. But I don't use constant expression that much. But that was just to show you that like you could do a couple of cool things with constant expressions in a hash table. Or
it had gotten bigger than I had. I mean, you had a bigger function than I had realized would just be fine. It's all good.
Yeah.
So what I heard there was swap out const expr for const eval, and you get a guarantee.
Oh, is that how? Okay,
it's a slight name change. Matt's pointing out there is a version. It's in the he put it in the chat. I moved it over to docs. It says something about const eval versus
Mm.
const expr.
I think I also remember that like so there's a difference between putting const expr in front of a function and putting it in front of a variable. I think if you put it in front of a function and you create a variable with const expr in front of it, like if you put basically const expr everywhere, then you guarantee things evaluated at compile time.
So I wanted to talk about the actual hash table, but we get distracted.
Sure, yeah, it's just a
All right.
One question before we get there, just like what I don't understand is why you should need to tell it that it's a constant expression. Like it is a constant expression regardless of whether you say constant expression or
So
constant.
you personally know that the compiler knows it's a const expr. You blew it accidentally. You made something the compiler can't evaluate at compile time. You were expecting it to evaluate at compile time. It did not. Then your performance sucks because you're running all this code you thought would just be a simple constant. So this is a typing annotation.
So I understand it in that perspective. Is that the only thing it's actually doing for you if you say constant expression?
I think the other reason is because the compiler doesn't want to evaluate the entire function to figure out if it's a constant expression or not.
Oh.
So it just compiles it at a different time. Like, because why do it through the interpreter if it's not constant?
But if you have loops, you have arbitrary unbounded execution at compile time.
Yeah.
It wouldn't, yeah, I mean, I guess so, but I would think that it would, progressively figure it out. I mean, isn't that what
No, suppose he's got a loop and it's Turing complete. The compiler has no idea that it terminates. The const expr or const eval is telling the compiler the user wants him to run this code to completion no matter how long it takes and get a constant at compile time.
Another example is, let's say this is legal code. Like it doesn't matter what the object actually does, but in C++, this version is not allowed if it has to have you can't initialize your members inside the function body. You have to do it outside the function body, which is why they invented this syntax.
Ooh.
So C++ really doesn't want to look at function bodies for whatever reason.
Wouldn't the second one, which you've got the arrow by, be O equals 1? Maybe I don't misunderstand that.
Like, because if this is something that has a constructor, it must have some value.
Right. Right. Other object needs is a constructor.
This is not initialized, and when you get into the body, it's supposed to be initialized. So that's why initialized. Yes.
I see.
So yeah, C++ really doesn't like looking at the bodies, and that's why you have to annotate and add a lot of stuff to things. But are we ready to start on this?
Oh, your hash table.
Yes.
Well, I'm hoping it's not fixed size, but go for it. Yeah.
Okay.
We have a row in there.
The reason why I said it's not good is because this only handles like the 3 cases I tried, and it's not even close to done. But it handles my 3 cases. So
there you go.
Okay, so the idea is pretty simple. Should I step through this, or should I just go from top to bottom?
No, let's give it a chance. Like only step through in the sense of like a few seconds worth of discussion and let people read, because hash tables are pretty common.
Okay. Let's start at the end. I basically have 4 values. It's just these 4. It's dead simple. I keep the key and value separate because when I tested my original hash table, I noticed that the cache is a lot better if you keep the keys and values separate, even if they're both 32 bits.
Yeah.
So I just keep them separate.
Right, but one of them's garbage collected and one of them's not, for instance. Then you can't have them in the same spot anyhow. But no, that's all reasonable.
Yeah. So
what's SMM calloc?
Oh, the library is a joke. This is like a joke library or project. It stands for standard minus minus. So The thought is this is C++ without the C++ runtime, without their standard library. So it's standard minus minus because you're taking that away.
Yeah, okay, fine.
Yeah.
So you make a bunch of arrays, you're doing inline data for the keys and the values, all perfectly
Yeah.
sane.
So I originally wanted this to happen. I originally wanted to allocate only when you insert something,
Yeah.
but then I realized that that's an extra if statement every time, and I was trying to have it in such a way that there would be a minimum amount of ifs to insert something. So I just bit the bullet and let it initialize at the very beginning.
Well, what happens now is your table gets full and you have to resize. You already got if statements to ask is table full.
Yeah.
So
So I noticed in
what?
Clang, that sometimes it does not inline things because the body is big, even if you have ifs surrounding it. So I separated the insert into two parts. This part is what I want to be inline most of the time, and insert two, I don't care if it's inlined.
Yeah.
So
This hack works fairly well in Java as well. If you want the JIT to, I mean, after you profiles, but if your breakout into two different functions matches what the profile does, then you get the good inlining of the fast path. And then, the outline version stays outlined, doesn't cause code bloat. So you do likely key table offset. So you're telling the compiler it's likely that you will miss in the table, and then you insert and you bump. Else, if you grab, and the equals is an overloaded operator call. Line 478.
FYI for this variant, the key always has to be an int, so it's like an unsigned car or signed 64. Signed 64.
Key is not an arbitrary key.
No. Like I have another variant of this table for strings, and I don't have a variant for general purpose. But I'll explain that like later.
Yeah, fine.
So does that mean your hash values always can't collide?
Well, I haven't.
No, they definitely can collide, and that's what this check is for.
But theoretically, with an int, you could make a hash function that never collides, right?
Well, no, you can always make them collide.
What I noticed is that even if you have sequential int values, it's a bad hash because there's going to be a gap in it, and if there's more than one gap,
go to insert two now.
Gets really poor.
So you probe. So because you're an int key, you can take the offset as just that whatever hash is on an int mod to and off to capacity. Capacity is power of 2. That's great.
Oh yeah, this is guaranteed to be power of 2.
Yeah. This is how I do my hash tables too. It's fine, and they're open coded, but I'm not using it. Well, I guess for non-blocking hashmap long, I in fact do 2 different key value tables, and they're open coded all the way. So same. Check for empty slot, insert, else check for direct hit, replace, else go to insert 2. So here's your reprobe loop. Go to insert 2.
Yeah. So I sometimes there was one case where I wanted to know if it's an insert versus a replace. So that's why I have these.
Yeah. And then there's an API, right? You have an API that I haven't looked at that says what are the rules for insert or replace. So instead, I was going to ask, go to insert 2. I want to see what your reprobe loop is, because that's where you'll fail or succeed for a bad hash function, which small dense integers are a typical bad hash function.
I just wanted to show this because like people are going to be wondering. Basically, in Clang and GCC, you say you expect the expression to be evaluated as 1 or 0, as in true or false. This one, Adrian mentioned a week or two when we were talking about I forget what we were talking about, but
no, but that's all reasonable. This is all compiler hints on what to do with the branch. Like Java's got profiling data, you don't, but you got hints, so all same.
So why aren't you using the standard library?
Well, I was using the standard library, but this is for fun to take it away. But the other reason is because I started trying out SDL3, and I noticed that compared to SDL2, it's actually much faster to compile the, like, if you I noticed that SDL2 was roughly around 300, 400 milliseconds to compile a blank source file. But for SDL, it was less than 100 milliseconds. And I thought if they're going to improve their build time, I should do that too. And then I just like felt like writing this because I want to see how fast my build times can be for my IDE, because it's starting to get to the point that I include strings, vectors, hash maps, and a bunch of other things, and it's becoming like 8 seconds, 10 seconds to compile, and I'm used to like 1 or 2. So yeah, I just want to see how easy it would be to take away the standard library. I have no idea if it's going to be easy or not, but yeah, I figure I'll spend a week or 2 on this and see how far it gets.
Not 3 days?
Cameron
now.
loves 2 to 3 days, but
I'm giving you shit now.
prototypes are 2 to 3 days.
All right. So here you have, we're here
Okay, so-
on a collision. And then
Yeah,
you
so this is the case where I should have stayed here.
Yeah,
So the case where it's the hash does not match the entry,
Yeah.
like there's a collision.
Yeah.
This is the case for that.
Yeah, you found a collision. So
Yeah.
you first decide you're full and you're going to grow and try again. Totally same. Now you have a distance limit, which I'm not sure what that is. And then you go add an in. Okay, so you're stepping forward. You add 1, then you add 2, add 3, add 4. You rehash, and then you
No,
look.
I don't rehash. I have the hash value. I just
Yeah,
add.
I say rehash. Sorry, you reprobe by making a new hash value, you adding
yeah.
a number and then modding it, and then you check the table again.
Yeah.
And then
Sure.
on a hit, you just insert, and on a tie, whatever prior, and then you have a grow 0 versus grow 1. And if you run the distance limit out, you're going to try to grow again because you've got some set of bad hashes and you've collided endlessly.
Yeah. Or
As
you
a
never know
person-
if someone finds out how to give you malicious input to mess up.
Oh
the
yeah,
hash.
yeah. Suppose your table is of size power of 2, whatever, 1024, and I'm giving you sequentially increasing values. Start at a random place and give you a bunch of sequentially increasing values. And so they make a wad area in the table that's densely packed, and they skip the rest of the table. Then they start with a new random entry and go again. When you collide, you'll hit some prior entry, and then you'll say reprobe, and you'll add 1, then you'll add 2, then you'll add 3, and 4, and you'll sort of quadratically move past the dense packed section and get into an empty space. That's the goal of the add 1. But if you put down a thing that landed a certain spot in the table after you modded 1024 and you hit some collisions, you went 1, 2, +3, +4, +5, and you bounced along until you got to an empty spot, and you came in with another guy, the same mod table size, but he's yet again unrelated, he will take the same repro pattern, add 1, add 2, collide. So you're a little fragile to people who mod the table size, land in the same spot, and collide, because the reprobe just adds 1, adds 2, adds 3, adds 4, and you'll bounce along a dense section and you'll continuously reprobe.
See, I heard about the attack in theory, but I don't actually know of anyone actually suffering from that.
No, what happens here, and I had to do this because Doug Lee ran into it in the Java libraries. It wasn't an intentional attack. It's a common stupid pattern. Somebody comes up with a number that is mod your table size, and then they add 1 because it's an integer number, and they internally are just adding 1, 2, 3, 4, 5 to whatever they got. They got 1,000 wherever it came from. Then they 1,001, 1,002, 1,003, 1,004. Okay, so then a little while later, because they're screwed up, they have some modulus power of 2 bit hack going on. They come up with a new number that is also mod power of 2, and they go in at your table, so you wrap and land on the same spot. And then you add 1, add 2, add 3, add 4, and just like the last guy, you just tie down the line and you collide down the line. It's an easy enough pattern to accidentally hit, and a slight change to your reprobe will defeat that.
Yeah, so that would happen despite the quality of the hash. Like even with a solid hash, it'll still happen.
It can. If you have a solid hash, it's way less likely. But the problem is if you let the user define the hash, you kind of have to. If you let the user define the hash, people will define really bad hashes.
If the keys are statically known, I typically I have a code that will insert a C and iterate to the keys, and it will see if it can find the C that make the hash perfect for this set of keys.
Yeah, Theodore, I'm talking about a different issue.
Yeah.
One is I'm smart about my hashes, my hash tables, and what I'm hashing, and I've done a good job with my hash function. This doesn't apply, you're all fine. If I'm making a general purpose hash table to hand out to millions of different people who are going to just be dumb and use it as a hash blindly without thinking, they will, with a fairly high commonality, pick a bad hash function.
Yeah.
And because they picked a bad hash, say they know they're doing ints, they're using unique and integer identifiers, they have a huge count of things they just want to uniqueify. They say, well, it's an integer, I'll just make the hash the identity call, it's free.
Then they will pay the price.
And then they get a bad hash. I'm saying you can defend against that one. You don't have to defend against everyone who's attacking your hash table, but there are some easy defenses for stupid people that you can do.
Yeah, typically, if you have a bucket, if you have an array for the colliding keys, it will pay the price for searching inside.
I agree. I'm just saying you can make it not collide on the repro with a little bit more smart. So you're doing a distance and you're adding one, Levo, which gives you this dense section all in a row. You add 1, 2, 3, 4, 5. Instead of adding in, add in squared. And another one is instead of adding in, add hash squared. Don't even add for distance count. You can do distance count for giving it up, but don't add in, add your hash to itself squared. And you will rapidly spin around the table based on the original hash the user gave you. And if the original hash is always bad, like I have certainly seen hashes that were always ever 0, that only gave me hash 0. But if they give you something decent, because you're taking the hash itself, it's your bit of randomness, and you're adding it to yourself, and you're squaring to avoid the stepped on it in a row, you get a fairly cheap, much better spread for people who are naive. I say stupid, but just go with naive.
Okay, so I just fixed a minor thing while you're talking.
Yeah.
Should we talk about find now?
Yeah, it's got to be like same for insert, 99%, right?
Yeah, so this is like dead simple. I figured that this could be optimized in.
What is
no
SMM
problem.
illegal? Because you could miss in the table. So you miss, aren't you just want to return? Yeah, why are you dying on him? I understand, but if you miss in the table, where do you return null?
This just calls like an abort or a
Yeah, I
fault.
understand what built-in trap does and why you called it illegal. That's great. Now I'm asking a different question. If I miss in the table, where's the return of a null?
Oh,
I would have said you're sitting on it with your cursor, and that should return
no,
null.
that would be this one, I believe. No,
Okay.
no. This one is if it's too full. Yeah, so you're correct. Yes. So if this is the miss.
Yeah. And then the question is, if I ran out my distance limit and I didn't find you, your rule is I grew my table if I had more probes in the distance limit. So find will never run out the distance limit unless it's actually completely a miss. Like I think both of those returns should be returned null.
But when you grow, you could create a new run that was longer than your distance limit.
No, you have to look at his grow code to see if he's doing that. Like if the grow is made by, I have a wider table, and then I add the same things in using the same insert logic. I know he's using the same insert logic. The same logic will only ever stop at the distance limit. Now, it could be the case that a bad set of keys forces him to grow indefinitely without bounds, without ever breaking his, I mean, you can't ever, it'd be an attack that
grow
basically
infinitely, yeah.
Yeah, so I just don't want to deal with what happens with, because for the string version, I don't want to allocate like an empty string and then have the user pass in. If I wanted this to be generic, and allow people to pass in keys that have no default constructor, it's going to be a problem if I need to create a default Like,
Well, you use
debuugger
references.
or value or whatever.
Yeah, you use references for that.
Yeah, I just prefer to use to have them to use call the contain, and then look up the value. That's what you generally do in C++. But I know some people like null, but
Oh,
C++,
okay.
not everything's inside a box.
Well, oh, you're finding, no, you should find the value. Yeah, why on the find operation, comment says returns value or null. On a miss on the find, what do you want to, you actually, right now, your find code, line 496, returns value or null. It doesn't actually ever return null. There's no return null in there. It only ever crashes and burns, or it finds. Bool has a true or false, no problem. I'm sorry, bool contains key, line 484, true or false. Line 496, that function find, that never returns null.
So 497, I'm returning a reference to something,
Yes.
and references are not allowed to be null. And I don't want people to look up a thing and then check if it's null. That's just a little weird. They
Okay.
should just check if it's null and then look it up.
No, but what I'm saying is returns value or null, the comment is incorrect. It's going to return you the value.
Oh, right. This is an old comment, but
Okay,
yeah.
so the goal of find is to say the user knows the key is in the table, I will return it. And if it's not in the table, it's just a crashing bug.
Yeah.
So you have to do 2 lookups to get a key out.
You have to do 2 lookups because you don't have a return value. He's returning the directed value in the table. He's not returning any references. He's returning the structure that's in the table itself.
And does C++ not have an optional type?
No, they
That
don't.
would be a reference. So as soon as you go to a reference, you have a null or not the null. He's got the actual.
There is stud optional or stud expected from the standard library. You could probably implement one yourself.
Yeah, I really don't like optionals in C++ because, or for a number of reasons, but
I don't either.
I'm just trying to stick with the C++ way for the C++ code. So I'm not trying to do too many changes.
I think for a debug build, you could modify your find function slightly and add an assert that it contains the key. Only for a debug build because it's gonna cost you performance. But it's good to have a debug version of containers that tell you what went wrong.
Oh, have it fail politely instead of just.
Yeah, or just have an assert that it contains key.
How would an assert be different than a trap?
Is this polite enough?
More knowledge in the return.
And it's only in the debug builds. In the optimized builds, asserts go away.
This is like a personal philosophy issue with me and C++. There's way too much argument over the super finest amount of performance, and I'm always willing to give up a quarter clock cycle of a highly predictable branch in order to get a better debug message, but not everyone else is. I would claim better debug message is well worth the tiny fraction of a highly predicted branch.
Yeah, I could do that. It's just this is brand new code, and I can put a debug message right here. Someone asked about what happened if I have to do 2 lookups. The logic in both of these functions are the same.
Yeah.
So
you'll hit the same places and you'll find the same.
When it's optimized, it could just look up the table and.
I do claim you'll definitely be slower if every find also needs a check for presence, and therefore a contains plus find is definitely slower than a find that returns a magic value saying I missed, as opposed to crashing. There's something you could return here that says I missed, as opposed to I always give you an offset, and that's slower than returning something that says a miss is faster than having to call it twice.
Yeah.
And then another comment I'd make is put all your hash thing, the distance limit and offset equals h plus n and capacity -1 in a macro somewhere, because like I was saying, you might want to change that reprobe logic and then put it in one place so you get the reprobe logic replicated everywhere when you change the reprobe logic. Everyone has to agree on the reprobe logic. That I totally get. You have to have the same reprobe logic. Now, having said that, maybe that's not the reprobe logic you're looking for.
I'll probably ask you guys about reprobe logic later, but I've never had a problem with this logic. And
Yeah, I can hand you
don't
data
know
set
the
where you have a problem easily, and stupid people will do that. And I got burned, and Doug Lee got burned, and the Java hash tables don't do this because of that burning, because it was way too common and it was easy enough to work around. So you did it, fine. It just
would
makes
that
the hash
matter-
table more friendly for more people.
Would that matter if this hash is good and I demand that you use it? Because I think I'm just going to support this one hash and
Oh, I
that's
see.
it.
So for if you insist on the hash, you can get away with a good one, and then you're okay. Yeah.
Okay.
If you take somebody else's arbitrary things they want to shove in a table that aren't yours, you can get in trouble. Also, it's not too hard to have strings have their hash be carefully arranged that they screw with your hash. I'm saying the defense against the reprobe logic attack is really cheap.
Yeah. So
If you're-
this the more interesting table that I want to talk about.
So real quick on your find function, you said it takes integer keys. Can you not have 0 as a key?
Oh, that's an interesting question.
You're
Well,
checking for
0 is
0 for
because-
empty.
0 was because I had no entry for it, but you know what? Let's find out. I never actually tried it.
Oh, yeah, you know what? When I did my version of this with a long key, I had a special cutout for 0, and I put the 0 value in a different place. It wasn't in the table. It wasn't in the array. I said, your key is 0. Oh, I have a set aside just for you. Everyone else got a 0. Yeah, everyone else's 0 meant not there.
It appears to work. I don't have a special cutout or anything, but
Okay,
just-
go look at the insert logic for 0. Go look at insert logic, and let's step through for 0. So you're going to hash. I don't care what your hash does. You're going to come to key table offset. You're going to say it's equal to 0. Therefore, it's empty. So you insert a 0 key. You insert your value. You say, great, I inserted 0. But notice that your check for insert worked because the key matched the default empty table value. So if you were to come through and say, I want to insert a second thing with a 0, you would hit in this first line 471 again, not in the second insert. And the return value of the first insert is a 1 and the second one's a 0. So your return value is going to be different. This guy, when you come through 0, he's going to return a 1, but he put the value in the table. The second time you come through and insert a 0, he's also going to think he's putting it into the table and return a 1, as opposed to finding an existing and returning a 0. And and your unique key count will then be wrong. This will grow without bounds. You need to cut out for 0, or you'll get screwed up here. So run put 1,000,000 guys, 1,000,000 zeros in, and you'll get a unique key count of 1,000,000. Although your table clearly had been full long.
And same thing for contains too.
Yeah, everyone who does the key check. Yep.
Maybe I prefer 0 to be illegal. I'm not 100% sure. Do you guys actually want 0 to be in your hash map? Because
if I do a hash table based on integer keys, I allow 0. Yeah.
Okay, I'll have to do.
I'm looking for a general purpose hash table typically. So I've got I've got integer keys. Usually 0 is a reasonable thing for whatever reason. I will dodge 0 as unique identifiers for other reasons and other places, but my hash table will just check it. Yeah. And it's easy enough. You just check for the key is 0 and you have a set aside that's outside the table.
Is your hash function for integer keys, is it total? So that every unique integer will have its own unique hash?
I'll bet you not.
I believe it doesn't.
It doesn't do that?
Yeah, it looks like it's going to have
I had collisions plenty of times after inserting a couple of thousands, but those were collisions in the slot, not I don't.
Right, you can always have collisions in the slot, but you could have a hash function where you never need to recheck if the key matches, because if the hash matches, it's the same.
Go to your hash function.
All right. Yeah, there we go.
So you say grab the bytes and OR them all together byte by byte. What are you doing with the data thing?
So this isn't my hash function. This is just murmur hash, and
Murmur hash. Oh, I
it people measured it, and it seems to perform.
yeah.
It seems to create very good hashes.
Well,
and
but I bet you
perform,
ask if murmur hash
yeah.
is complete. I bet you it's not.
Maybe I will plot it on the JavaScript project to see how it generates keys.
Are we done looking at the hash table?
Yeah, we can be
the
done.
hash function?
Oh, yeah, it's kind of cool. You know, it's a Adrian giving a whole quarter clock cycle heresy. Exactly, Adrian. That's my opinion. But you know, there are plenty of people I meet who say something different. Okay.
Okay, so this is the real reason why I didn't like it, like my current implementation. So if you look at ABC, this is just a constant string, and I don't want to be creating my string, because my string. Let's see if I can jump to it. I would have to duplicate, which is an allocation if it's bigger than 15 letters. So I don't want to be creating keys unless I have to. So I use a slice instead of string. And basically that caused me to have two different inserts. One where the string is a temporary that I could just reuse the pointer. And the other one is it's not being a string, but you can't convert a car pointer into a slice, because the slice requires you to know the length, and it has different behaviors. So if you hand it, this is some magic I have. Basically, if you hand it a buffer that's like 256, this will check if there's a null before 256, and if there isn't, it will set the length as 256. Like, it's, I kind of don't like it, but for most of the time, if you're using a slice car, that's the behavior you want, because you're just passing a string into some function that wants some kind of slice. But yeah, there's a few hacks in this, and most of it is just for convenience. But one of the hacks is, or one of the things I made sure to do is, if you don't know the length, you have to. If I don't want to implicitly allocate, so I made it explicit, which means if I wanted to do this, I can't. I have to do this. The only reason why this works is because I'm passing it as slice, and what did I do to make this work? This originally did not work. Anyways, it's just been really, there's a lot of havoc in the past few days just implementing this. Oh, no, I do remember why this works. It's because ABC is actually car 4. That's the only reason why this works. Here, it's not a car 4 because it's a car pointer. Or, you know what? Originally, it was this. Yeah, I changed things too much, and I changed things this morning. Yeah, let's just show you the error message.
Oh, I'm busy reading Troy's link here on better hash functions, which I actually.
Yeah, so you can see this error message. Don't worry about it. But if I put in the cast, this is how you say it's explicit. And for some reason, it's still not liking it. It should invoke the string length version. But anyways, yeah. Like I said to Cliff this morning, I wasn't planning to show this.
Yeah, I
was
talked him into it.
Have this.
You're looking at the early beta version.
Yeah, so
something fine.
So I was just trying to say is I don't want to copy the string every time, so that's why I have a slice. And when I grow, I want to move the string instead of making a copy. So I have more than one insert because this version is temporary. This version is not creating the string. So it's just a little annoying because I can't do. Imagine if I was using a string as the template, like if I had a class key. I don't want to be converting everything like if I don't want to be converting a constant to a string, which makes a copy just to look it up and throw it away. So I had to use other things, and yeah, I just like literally figured this out like yesterday or 2 days ago. And
yeah.
yeah, so I can't use a string as the key.
Yeah,
So that's why I had to do a special version.
In the land of the high performance hash table lookup games for Billion Row Challenge or my one using the FinTech data file, once you get a certain ways down in the optimization process, you hit this exact point where to probe the hash table, you allocate because it's a string probe, and that's the loser. So the corrector answer is you make a string analog, at least in Java, you make a string analog and you populate it to probe the table. And if you hit, you just keep that analog to repopulate for the next root probe. And you're mostly probing anyhow, and you're getting 99.9% hit rate. So you mostly never allocate. And then the one rare chance where you miss the analog string, you just go ahead and put it in the table and make a new blank empty analog for the next time you might miss.
So
But
analog
you don't
is
allocate to a probe.
So you can make the object out of the analog.
The analog is has the string API without some of the string guarantees. If you
Okay.
wanted to go make an actual Java string guarantees, which include all kinds of things about finalities and immutability and stuff. If you wanted to make an actual Java string, you could, but you still make an analog in the table. So the table contains string analogs and not Java strings per se, so that I can probe it, or the hash function accepts an analog and a string. You want to be able to probe the table on a string-like thing that is not a string, so you can keep mutating the freaking string with each probe attempt. So you have these, I probed once, twice, okay, now make 1 billion probes. And you're cycling through, 1,000 things, so you have a 99.9% hit rate out of your table. How do you probe the table without allocating? Okay, where do your string come from? Well, you got some bits in a disk NIO buffer, network buffer, whatever. You got some bits. The analog says, go to this buffer at this offset for this length. Those are your bits. Now you go probe the table. The table says, oh, are these two things equal? Well, one of them is this analog and one of them is the stringy guy, but I'll go ask the analog or whoever how to go get his bits, and I'll go look at the string, get his bits, and I'll start walking bits. And then, I'll usually get a hit. So then the analog, I'll just repoint his buffer offsets for the next string.
So I think I'm gonna design the next version of this. I'll have one for ints, and then one for everything else. And I think I'm gonna use the pattern key value and a view, which would be the analog. So you don't have to create the object unless you know you're gonna insert it into the table.
You're gonna.
So I gotta do that.
Gonna do the user's analog. Well, okay. I did longs and I did generics because it's Java. And generics, I put references, pointers in the tables. So you always had that level of indirection. You didn't have the data itself, but the expectation was the data wasn't uniform size to fit into an array. And then the analog is, I just needed, for the strings, I did an analog. You're right. I didn't make an analog for users' arbitrary things where I would have a preset space where I could populate it to look like a foo object or a person or whatever I'm doing my lookups with.
Yeah.
I don't know how to do this for general. I did it for strings. I don't know how to do it for general.
Does your hash table have removal yet?
Sorry, say again?
Does your hash table have removal?
I think you have to write that out because I couldn't hear it.
Did you have removal? Can you remove an
Oh, no.
because you lose a hole in your probe loop. So you can't remove.
Is there anything else that you guys want to see before I turn this off?
No, I'm about to end it here. Go back to face views. There you go. You can go hack. Yeah. Well, it looks like a nice start.
Yeah, it was just to get some ideas and to start refactoring into my IDE because hopefully I can, since all my dependencies except for one uses C, I'm going to see if I can just get it to run without the C++ runtime just for fun and to see if it affects my my build times. So hopefully I can get it down to like a second again because 8 seconds for an incremental build is like bothering me. And I know other people suffer for minutes for an incremental build, but
No, it would kill me too.
I wouldn't be able to stand that.
Yeah, I don't understand what happened to you get 8 seconds for an incremental build. I mean, doing large Java programs, incremental builds still well under a second. And it's because
Yeah.
I'm not compiling every class file on the planet, so I don't get what's going on there. Fine.
Yeah.
Something happened to you. All right, what else? Got nothing? I'm gonna have to bring up something here. I was hoping to drag this out here. It was murmur, that's constant evaluators. I'm closing windows. Your GC, that's still very interesting. I'll have to look at that offline though. What else here? I'm hacking AA. I don't have a lot of stuff because I took a second job, so I'm now running 2 jobs. So I'm only doing AA on weekends. Simple is waiting on Debiendo to do loop invariant loop finding. What else can we say here? He's learning how to write a loop analyzer.
I just remembered I want to ask Matt something. Is there an easy way to figure out if something is an int or not? Because the only solutions I know of is to use something the standard library implemented, and I'm trying to not do that. And also, it seems like you have to do like 10 overloads of things, and you mostly get the right answer. And I don't think I want to deal with that.
You mean in
I
like
just want to know if
template?
there's something simple.
Do you mean like in template context?
Yeah, if there's an easy way to find out if you're accepting an int or if something is you could just copy the bits and it's fine, like something that has no constructor. But I think the only solution is just to do the crazy hacks that the standard does, and I don't want to do that, so I'll probably just
Yeah, I mean, usually it is type traits, but to be honest, even though those type traits are implemented in a header, these usually are calling compiler intrinsics. So if for some reason you didn't want to use type traits, you could probably figure out in the standard library implementation which compiler intrinsic is that.
Okay, yeah, if it's intrinsics, then it's probably much easier to deal with.
But if you want to do this so you can constrain your functions so they only accept int-like objects, they would just use requires expression.
Okay, yeah, I should look into that. I haven't looked into that or modules.
It was added at the same time as concepts, but you don't even need to define a concept to use it. It's just, you can just use requires with type traits, actually. It's the simplest way. Do not use enable if, because that was awful. And that would blow up your compile times too. Requires is the way to go.
Yeah, okay. All right.
So I spent some time this week looking at scheduling, which is a bit of a topic change. So scheduling in Sea of Nodes. And I really hated the way I did the scheduling. Well, I tested my scheduling stuff last time because I ended up with these big lists of nodes and then.
Okay, back up. You're talking local block scheduling or global scheduling?
Global scheduling and like the whole thing, global and local.
Okay.
So, so the code that I had last time worked okay, and I sort of copied it over and tuned it up a little bit. But I wanted to do a different approach for testing. So I decided, so I was thinking through like how I could test based on invariants. And I came up with a few. So I ended up with 7 invariants. So I basically do the scheduling, like the early, the late, and then the block scheduling. And then basically there should be a few things that I can say are true. So like, for instance, every scheduled block should end with a control node, like basically where it's going to jump to or something.
You have some
Yeah.
marker for fall through blocks.
Either it's an if, or it's a return, or it's falling through to another region or something. But there should be
There's
something.
basic block layout as separate from list schedulings also.
Yeah.
Okay.
Yeah. But anyway, like there should only be one of those in every block. You shouldn't have like two. That would be a mistake. Everything that's a control node should have a block. Like it should have some nodes scheduled in it. Things like if the control nodes that have projections should not have anything scheduled on them, because only like basically you go into like an if node at the end of a block, but you either come out on a projection, but they don't have any blocks scheduled against them.
Yeah. Okay.
So I have a bunch of, I can have several functions. Every control should only be present in one function or in the start region. Like it shouldn't end up with a control node being in more than one part of the world.
Yeah. Okay.
Pinned nodes should always be in the region they're pinned to, or place they're pinned to. Yeah. And then every node should be somewhere in the schedule. Yeah, I don't know. Those are the invariants I could think of.
Sure.
I'm not sure.
Are you supporting exceptions in something that you are compiling? Just curious.
No, I have a thing that looks syntactically like an exception, but it literally just halts the program.
Oh, okay, because that could complicate this invariant of either multiple exits or multiple entries. Depends on how you would handle. Some people handle exceptions by adding explicit or implicit edge at every basic block that could escape, and that complicates invariance.
I'm not one of those people.
Yeah. I had a really complex setup in my first one, and this time I decided to just have sort of landing pad regions that it was a little bit, tiny bit more complex when I was building, because I'd have to sort of keep track of where I jump to if I'm doing a continue or a break in a loop, or if I do a return in a function. But then, but then that seemed to simplify everything else. So yeah, so that was good. But anyway, I don't have exceptions.
You don't allow empty blocks only during scheduling or ever?
Well, like while it's optimizing, it can, but scheduling is sort of done after all optimization. So any
okay, that makes sense.
So the optimizer should be getting rid of blocks that are redundant.
Because sometimes for optimization that makes sense to have something you can hoist to or sync to, but yeah,
they are definitely there at some point. So yeah, I guess if that invariant shows up that there's nothing scheduled in a block, then either the scheduler did something wrong or the optimizer did something wrong.
I'm trying to think. Well, okay, so but maybe not. The land of C2, I would have load ops that were doubling up as a null pointer check on the pointer. And when I went to schedule them and declared it, I declared it a basic block where the last op was the load, and it branched on a null to the NPE handler or fell through.
Oh, okay.
So you're right. I treated it like a basic block. It had an instruction that had a control flow. The control flow happened to be a load, and the test was the address is null or not. So yeah.
Interesting. So in that case, you had a sort of control flow load node, which would sort of act like an if, really.
Yeah. So the original code said something about check the pointer null, and then on the OK branch you had a load. Somewhere during the machine code generation, I smushed the load and the if together and declared I had a load that was going to null check for me. And it looked like a control flow block that produced a value and, you could branch to the fail or a value and a control for the good.
Yeah.
So I'm trying to think if I had an empty block where you merged and you split in the same blocks or something you could do there. But no. And the other one is you you come to a transfer and you split off and you fall in, and then it's a region because you have a back edge. So if you had a load that was doubling as a, but any if check that's doubling as a, you have the if check that's going to branch off, it's going to fall through, and immediately you hit a region because it's a loop back edge. You get an empty block. Now, when you schedule, it's empty. There's no code. They all land next to each other. In the control flow graph, you don't need an empty block there. You have an edge that conceptually could have an empty block on it. But
Mhm.
maybe you can just remove those at your point, whatever, it doesn't matter.
Yeah. Yeah.
Okay. Yeah, I'm trying to think if
Yeah,
there's something else going on there, but no.
Yeah. Yeah. I guess those things can be tuned if I come across something that's
It was causing issues.
causing that, I can just add an exception to my invariant or
Yeah,
whatever.
once I got the global code motion thing done there, I didn't have a whole lot of like worries about invariance at that point. It was pretty obvious.
Yeah.
Pretty clean. So is
Yeah.
is it running now? You have your list scheduler running and your global code motion running?
Yeah. Yeah. And I threw all my biggest code blocks at it, and I was getting errors at first, and I think I've hit every invariant as I was working through it, but now they're all clean. So
You got ready to code generate then.
yeah. Yeah. And I
Then you're gonna need
also,
hardware.
what's that?
Then you're gonna need hardware. You're gonna run it.
We have hardware.
They gonna let you touch it?
I've touched it.
Okay.
And
Cool. Yep.
yeah, so and I've been doing a bunch of cleanup. So, I had things like basically I have a bunch of dependencies. They're all these open source libraries that I made, but I never actually released like jars for them. So I went through them all and I built them and I deployed them to Maven, and simplifies all the pulling things in. And then I got it all working so I can just like import the project into IntelliJ, hit run, and it just runs.
Oh yeah.
And
Okay.
what else did I do? Oh, so I had a misunderstanding about how the value call works. So I was like, I had this like value call in my sea of nodes where I would call it and it would like it would like update. It wasn't a pure function. So yeah, I fixed that. I fixed that today. Actually, it took me like an hour. It was pretty easy. So yeah, so I've been like going through and like just trying to find places where I screwed up and fix them.
So for people who didn't know, the value call in the sea of nodes is basically conditional constant propagation. And if you look at the theory of the thing, the value calculation is simply what is my type based on type of my inputs, and it has to be a pure function in order to avoid all kinds of evil things with how the theory works. Pure function and monotonic, and then you're guaranteed fast running time to a consistent single best answer. You get the global fixed point fast. But if you have side effects in there, you can be all kinds of grief. As soon as you yank side effects out, so you no longer have side effects. I've had them with side effects in the past without accidentally before I realized, oh, this is convenient. I'll just do this, and then no. So once it has no side effects, you get other things that are useful, like you can go ask questions, you can run asserts and stuff because it has no side effects. So you can just run the damn thing anywhere you want. There's generally good behaviors for being a pure function in that case, but there's more so than usual because it falls into the high theory, leaves you issues if you re-execute things and they have side effects.
Yeah,
it's all good. Hey,
Jim. Yeah, the funny thing is that I cleaned it up and there was a little bit of messing around to get it working, but it was fell together pretty quickly. And then I discovered that I had some tests where I was asserting that an error would be reported when there was actually no error. So, and I look at I was like, oh, this is like a weird side effect that I like. This is not where I expected things to break. And I look, it's like No, there never should have been an error reported here. Like, I don't know why I was testing for it, but
Some misty past, you had an error, you didn't want to deal, so you just put in the test as it's an error now, and then later it's like, no, it's not really an error.
yeah, well, it was like I have this thing that walks through nodes. It's very similar to what's in AA, and it walks all the nodes and it asks them if they have an error, and then it provides an error message. And I had one of those that was saying, like, in a binary operation, in some case, it's like, wrong domain or whatever, but actually it wasn't. It was just like type used to somehow be in this wrong state. And it was saying there was an error. So anyway, all fixed. So that was
Excellent.
nice. Yeah. So
I've got a question. I've got a stupid question for Derek.
Sure.
So I picked up that you're making a sea of nodes compiler, but I don't understand when you say you're scheduling, what are you trying to schedule?
Oh yeah. Okay. So the sea of nodes graph has like control flow baked into it. But it's just a graph. So the nodes aren't actually in any particular order after you build it. And because of global value numbering, and that causes some sub-expression elimination by having, like, you can have multiple points in the graph actually pointing to the same node. Like, it could be, you could have a simple expression in one function and another function completely disconnected from it has the same simple expression. It turns into the same node. And so that node actually can exist in multiple functions. It can exist in multiple places. So when you then want to have a sequence of instructions, you have to put them all in order, including, having those expressions sometimes in more than one place. But like, you basically have to say what the actual order of every instruction is, and like which part of the control flow, like basically you go from these region nodes to actual, like, every single node is in a basic block. So, and they're in order. So that's scheduling.
I have unrelated, I have swag.
Yeah.
People who want
Maybe another
stickers.
round of t-shirts. Maybe this summer.
Not t-shirts require a bunch of effort on my wife's part. I have stickers, which are sort of just drop it in the mail. We'll move it to the Discord here, but people can ask for stickers if they care.
We
Give
could
a
just
link to
get
the Discord.
we could get the iron-ons directly and iron them on ourselves.
I could we have to see. She's been using a Cricut. So the last round of t-shirts was she did a Cricut to cut out all the sticker parts, and then so that's and then she did the iron-on manually, obviously, but the big part was the Cricut had to cut all the parts out. So we could talk about getting iron-ons and handing them out to people too. All right, separate things. Sorry, I was not expecting the doorbell.
I think somebody should get an embroidery machine and we can have properly embroidered shirts.
Oh, excellent. I look forward to that, delivering that to my place. My wife would love that. Are you offering to buy? Is that what I heard?
We'll see. We'll see how the company goes.
Troy, did you get your question answered? I walked out in the middle.
Yeah, I did. He gave a good answer.
Yep.
Okay, next topic.
Yeah.
Has a topic.
We could declare done too. It's hour and a half in, it's all good. But not much on simple because Dibiendu wants to do something and he hasn't, and he's told me to stay away, so I haven't touched simple. And he's been making progress, so it's fine. I did some small amount of work last week on AA, not a lot.
Considering
what is AA?
how time Dibiendu seems to have to devote to simple, he's making pretty fast progress.
Yeah, he only touches on the weekends. Yeah. Well, then when he's done touching, I usually jump on it and then I make a bunch of progress.
Oh, that's right.
So it goes back and forth. AA is my project, Troy. It's a click AA on GitHub, and it's me experimenting with minimalistic syntax and blending of functional programming and imperative programming in a high theory way. And I think I've beaten all my theory issues out, and I ran out of time to go work on it by myself. So I've gained jobs to make money and working on weekends again, same as JVN do on Simple. And Simple is another project that's a Sea of Nodes demonstration tutorial. So, and that one's actually far enough along to be useful to people. In fact, now that I've said that, I'm wondering, I should go.
How many Sea of Nodes projects are ongoing in this group right now? Because so Debendu and mine, and then you've got AA.
Yeah, I got AA. That's 3. I don't know. We don't have a bunch of people here. I don't know.
Yasser's 4.
Yes, there's 4. There you go. Oh, and who works with Yasser? Some guy's using his stuff directly. Sean. Sean, so that's 5. I think his is separate. I think he's building on it. I don't know if you count that as separate or not.
I wanted to jump in and ask about that. How flexible is the AST at this point in time?
You talking about AST for AAA?
Simple.
Oh, Simple. Simple doesn't ever use an AST.
So the language is flexible at this time?
No, the language is intended to be a tutorial. It misses most interesting features of languages. It has very simplistic, vaguely C-like, vaguely Java-like syntax. It doesn't do overloads. It doesn't do a lot of things. It's really a tutorial. So it skips fancy language features in exchange for demonstrating the compiler technology.
Are those going to be like, fitted with a kind of scaffolding expectation once a couple of Sea of Nodes implementations roll out and have similar, regions and feature sets?
The simple language is showing off the compiler tech for Sea of Nodes. Other people's Sea of Nodes compilers have other goals. I don't know what you're looking for.
Future applicability based on the educational prototype.
To what? Is there applicability for the educational prototype to what?
If the educational prototype compiles and runs with the defaults, then maybe, tweaking the language a piece at a time is worth looking into.
Okay. Yeah, so the parser is pretty small because the language is really simple. The output right now is Sea of Nodes, which at some point will push into a standard control flow graph basic block, and then whether it spits out to C or Java or whatever the execution strategy is, not yet to be determined. It's not the goal, so we don't kind of care. But the actual language itself is really simple, including the parsing. If you wanted to go, and it's open source, if you want to go hack the parser, go hack it now.
Time permitting, and it doesn't, but yeah, that's
yeah, right. Like for instance, we have integers and we have structs with integers, but we don't have floats. But it's like a really simple, like clone the int code, add a line that says if, quote, float, quote, instead of int, and you can get floats pretty easily. The structures don't allow pointers to other structures. Again, it's not too hard, but it's just not the goal yet. We'll get those pieces in, I think, but that's not the goal. The goal is just to show off the compiler tech after parsing.
Okay. So I guess those are, language choices to include anything beyond those basic functionality representations like the pointers and stuff, and the floats, etc. But I guess I'm looking at the stability of the Sea of Nodes concepts, developing to some kind of communicable, discussion form.
Okay, I'm not following directly. Like Sea of Nodes is a way to represent program semantics that is amenable to optimization. Been in use for a long time, secretly in use by millions of people that have no clue they're using it. But it's a compiler IR tech. It's not really a programming language per se. I don't know, at some points in the past, you were looking at wanting to do things with language support for like I don't know, an XML or operator overloadings or something. You get some very specific instances that I don't know.
But sure, I do some crazy shit with a language that's not designed for it. And, you know, I'm patiently watching what else comes along.
Okay.
Yeah. Well, so a couple of comments. I've found the simple project quite useful as I was getting started on my rewrite. So I've done a full C of Nodes compiler, and it's a finished project at this point. But you know, there's a lot of concepts in there. It's hard to remember everything, and plus there are some things I just didn't feel like I did very well. So it was really good to. So I spent a lot of time looking at both AA and simple, and both were kind of equally useful. Yeah, that was so the simple project for me, like in terms of like, it is very good at just revealing the core ideas in the C of Nodes stuff. So it seems to be achieving its goals.
Excellent. Good to
And it's
hear
got a
that.
nice little evaluator in there that it's useful. Maybe there's 2 of them now. I don't know. Like, I think
Well,
some
we're changing the evaluation strategy as we add more things. Like the first cut C of Nodes didn't have any memory, couldn't do loads and stores. It's just all
Right.
pure algebra. Soon as you have memory, you get into anti-dependencies, which are taken out during optimization and added when you back to code motion. Well, the evaluator ran without memory edges because it ran without anti-dependencies and didn't care until we add them. Now you have to do something different. Shortly after what Debian was working on, the shorthand goal from that is to get a global code motion scheduling. And then the evaluator will want to take the scheduled version, which will be a lot more efficient. Like the evaluator overly eagerly evaluates everything massively because it doesn't have a schedule to evaluate against.
Yeah.
So it's wildly inefficient, which doesn't matter for these little test cases, whatever. As soon as we get like a real schedule in there, we could start doing crap like, oh, we can compute factorial sanely, you know, stuff like that.
Yeah.
Do
I was actually thinking of adding an evaluator now that I have the schedule, and then actually just comparing the scheduled evaluator against the non-scheduled evaluator. I actually did do the anti-dependencies already, and I had them in, you know, so I was doing evaluator stuff with memory edges and stuff. It works okay. Yeah, so, but yeah, I imagine it's slow. My examples are all small, so it doesn't matter yet.
right. Things get bigger, you need something there. And then Troy, the Discord, I'll have to send you an invite. I'll do it after the meeting here.
Yeah, one of my goals in this project was to have like a chain of evaluators that evaluate the graph at different points in time so that I can compare the compilation as it progresses.
I'd say it should give you, as an evaluator, it should give you the same final answer every time, just
Exactly.
with fewer steps.
Yeah.
The abstract evaluation engine.
Yeah, yeah. So that seems to be working okay. I haven't taken huge advantage of it yet, but that's also because I haven't been doing any of the really fancy peoples and stuff. So where I
But
think they might.
you should be at some point.
Oh, I will be. Yeah, I just
Yeah.
haven't done it. So I sort of trying to get end to end, and so I have a pile of peoples that I brought in right when I started, and they're all working if they're applying, and yeah, that's
Okay.
coming up. Oh, there's one other the other thing that I wanted to say, I almost forgot. I haven't had so what the way I actually got into the compiler stuff was sort of twofold. Like there was a need in the company for someone to like do something more ambitious on the compiler side, but I didn't actually think I could do it. But I had gotten interested in these algebra engines, so computer algebra. So there's this really nice one that someone built in the Clojure community called Emmy, and it's based on the one that Gary Sussman built called Schemutils, which is
We've got a link.
yeah, I can throw some links.
search terms and then we'll throw it in.
Yeah, so it's yeah, so ME. So that one is, I'll put it in the chat here. The scheme utils one might be a bit trickier to find. Whoop.
Thanks, Theodore.
Oh yeah, here. Well, I'll just paste the scheme utils reference manual from the MIT website, and you can search it if you want. But so anyway, it's pretty cool, but it uses something that's like it uses kind of like a NanoPass style compilation, really, for doing the computer algebra. And I've been thinking, like, it would be kind of fun to see what it would be like to do an algebra engine using Sea of Nodes, because it's very similar in terms of what's actually happening. And so, yeah, that's just like something I've been on the back of my mind, thought I'd mention it for some reason.
Okay.
I'm not going to do it anytime soon because I just don't have time.
Things to do. I get it. Okay. Anything else before I'm going to call it here shortly? All right. That was good. Troy, I'll get you an invite here. And then stickers, I'll put some note into the Discord, but if you want stickers, you're basically going to send me a self-addressed envelope and I'll throw stickers in and send it back. And then see people in a week. All right. Bye-bye.
Bye.